Another video, guys, that's all about gradients, tangents, and normals, and we're going to explore differentiation and its application. Alright, so we're gonna go through exam styles questions. Make sure you remember how their equations look like for gradients, for how to calculate basically the gradients, right, at a given point for the curve, and also how to find equations for normals and the tangent line, okay, at a given point. So right now we're gonna go through this. I must say that's not challenging, sort of medium level problem to understand how it works in reality. All right, so pause the video, try to do by your own, and let's get started. You have the curve with the equation that's definitely cubic polynomials, okay? If you're not sure how it works, just try to make binomial expansion of cubic power and you'll come to powers starting from x cubed and just going down, okay? That's definitely cubic polynomials. Or if you use the transformation theory, you do the same. You will arrive to the same idea, okay? So we're not going to do the graphically, but in the very end, I will show you how it looks like so that you understand the visual presentation, what's going on there, okay? First, we need to find the coordinates of the points of intersection of the normal to the curve, okay? And the tangent to the curve at different points. So first, make sure you're looking for the equation for the tangent to the curve at a given point with coordinates x equals 3. So the general equation of the tangent line, so I mark as yt, is going to look like as, so f prime, so we take in derivative f prime at a given point 3 times x minus 3, okay? And on top of that, you add f function at a given point, x equals 3. Okay, so y value. All right, so what we're going to do, we just simply first calculate f from 3. So our function y, I mark as f, no matter how you mark that, but we mean that instead of f, we everywhere mean the y value of the curve, okay? So in this case, f from 3, you just simply plug in 3 instead of x in the equation. 3 minus 1 cube minus 3 is going to be 2 cube, 8. 8 minus 3 is 5. Okay, so we know that f from 3 is that. Now we need for both, for tangent and for the normal equation, we need to find derivative, okay? So that's why first we take a derivative in general way. So let's pretend that we have, instead of x minus 1, t. Okay, so I understand that we have right now this, and we want to take derivative because the derivative from minus 3 is simply 0 because minus 3 is constant, okay? So we need to take derivative from x minus 1 cube. Okay, but of course, you're not going to differentiate the expansion, binomial expansion. It's really like you just waste your time for sake, okay? So that's why I'll just give you the idea how you can differentiate. You need to differentiate as a compound function, but there is no problem because in this case we simply have let's say another variable t, and we simply need to differentiate t cubed with respect to t and then multiply by differentiation t from x. So simply we differentiate t, okay? So that's why our formula tells us that first we need to take derivative from t cubed with respect to t. It's going to be 3t squared, and then we need to multiply derivative of t with respect to x, okay? So t prime from x. But because it's x minus 1, it simply is going to be 1. So right, so t prime from x is going to be 1, okay? That's what differentiation rules will tell us, okay? In the case if you have something like some constant multiplying by x and still have linear expression inside the brackets, you need just to times by the constant that you have before x, okay? But I think you'll be more familiar with that when we go through compound functions and differentiation rule for compound functions. You understand, you'll be aware of much more, okay, than right now, probably for those who are not familiar with that. Okay, so that's why it's going to be 3t squared. So plugging back x minus 1 instead of t, we'll get x minus 1 squared. Okay, and this is derivative, so we fix that f prime from x looks like as 3x minus 1 squared. Okay, on top of that, what we need to put argument instead of x equals 3. So f prime from 3 is going to be equals 3 minus 1. 2 squared is 4, so 3 times 4 is 12. Okay, we'll get 12. So that's why the equation for the tangent line is going to be equal f prime from 3 is 12, so 12 times x minus 3 and plus 5. Okay, that's what we're going to have. So we simplified 12x minus 36 and plus 5. So that's why finally the equation for the tangent line, tangent, at a given point at x equals 3, so at x equals 3 is going to be equal 12x and minus 31. Okay, so I'll just round up that and say that we accomplished with differentiation and with find an equation for the tangent. All right, so the next step is to find for the normal. So let's move to the next slide. Now we're going to do the following. We need to find the equation for the normal. How the equation from the normal looks like, I mark as y from x. It looks like as if it's f from given points, in this case negative 0.5, then we flip the gradients, right? Before we calculate that the gradient for the line is f prime, however at a different point. So what we're gonna do, we need to flip over derivative. So that's why we found it in general way. So that's the equation for derivative in general way. So 3x minus 1 squared, so f prime from x. So that's why this f prime is going to be reciprocal right now with a minus sign, okay, because normal is perpendicular to the tangent, so it looks like it should have the inverse, I mean the reciprocal gradient, okay, according to theorems of two perpendicular lines. And then we take away x minus 0.5, so that means plus 0.5 finally. Okay, so right now what we're going to do, I'm just going to find negative 1 over f prime from negative 0.5. Okay, that's our target for now. And because you remember that the equation is 3x minus 1, so you just plug in, if you like, okay, anyway, we put it, I'll just write. So what we have for derivative, 3x minus 1 squared, okay? And now we plug in negative 0.5, so we'll get 3 times negative 1.5 squared, okay? Definitely is going to be 1.5 squared, so if you calculate that, you'll get 3 over 2 squared, 9, 27, and 4 over 27, okay? So negative 4 over 27. So if you like, you can calculate. Let's check what calculator gives us. 0.14, so it's going to be negative 0.148, okay? And now you plug in back into the equation for the normal. So by the way, f from negative 0.5 we need to calculate. Let's calculate that. Just simply plug in negative 0.5 into the equation of the function. So it will give your negative 6,375, okay? And we plug minus, but it's already so. I mean, we've already found minus 1 over f prime, so we still continue doing that, and we write a negative 0.148 times x plus 0.5. And now it's right time to simplify, so right now what I'm going to do, I'm going to show you that final equation for the normal is going to be equal negative 0.48 times x and minus 6.1 6.446. Okay, so it's around that. Okay, and that's going to be the equation for the normal line at the point. So this is for the normal at given point. Our point is negative 0.5 and x equals negative 0.5. Okay, so we've got both equations. Right now what we're going to do, we need to find the coordinates of the point where tangent line meets the normal line. Okay, what we're going to do, even if you are not going to visualize the curves, you need to simply equate the equation for the tangent y equate to y of the normal. So if we equate that, having that 12x minus 31, this is the equation for the tangent, we equate to what we have here. So it's going to be negative 0.48x, and on top of that, let's round to two decimal places. It's going to be minus 6.45. Okay, so we equate and we simply need to solve for x. We're solving, finding the point x. Okay, and we need to solve and having x, we need to plug back into any equation of any line. For example, I'll choose 12x minus 31, and there I just put the x value that we calculate from that equation. Okay, and that's how we can find the point of intersection. Okay, but so let's do it quick. So we need to solve that, and what I'm gonna do, I'm just going to write that 12x, so 12.148x is going to be equal, so 31 minus 6.45 around. So this is going to be 24.55. Okay, so from where we can establish the value for x, so we just simply need to divide this value, okay, by, so this value by 12.48, 148, okay. So we'll get round x equals 202, okay. So 202, and then if we plug back instead of y, we can get y coordinates of this point, okay. So now we multiply everything by 12, okay, multiply by 12, and take away 31. I'll get around negative 6.75. 675, okay, that's the y coordinates. So that's why finally the point of intersection, let's set up as the point P, will have the following coordinates: 202 for x and negative 6.75 for y. Okay, so bearing the coordinates in mind, let's go to actually graphical solution or just graphical explanation. So you have the curve with the equation x minus 1 cubed minus 3. So this one, I just put some dots, okay? So that's your curve. As you understand, this is polynomial, okay? Here is going to be the normal line at a given point, right? The point is negative 0.5 for x. So that's x coordinate is going to be negative 0.5 and 0.5, and another coordinate which is x equals 3. So at x equals 3 we have a tangent line to the curve, and here is the tangent line with the equation 12x minus 31. That's what we've got, okay? And what we're gonna do, we just need to set up the coordinates for two lines. So if you want, you can draw them using your GCSE, okay, and using that point P as the point of intersection. As you can see, it's very close to what we calculated, so 202 is around 2, and the y coordinates is going to be negative 645 that we negative 675 as we calculated. So maybe not really precisely, but trust me, algebraically we did correctly. So the y coordinates of that p point, let me just put p coordinates there. Okay, 202 and negative 675. Okay, so that's how we can do it graphically. Just plot in two lines, normal line and the tangent line, and just see where is the common point, or just algebraically solve the system. So solve the system of equations for two linear equations. And that's the solution. Okay, so hope you understand that. That was medium level, definitely, because all steps are pretty straightforward, but it takes reasonable time to calculate that. Okay, so make sure you remember and be able to quick to set up the equation for tangent and for the normal line. Hope you like that, and see you in next videos where I'll be explaining maybe a bit harder questions. We'll see that. Don't forget to check also level Zillion's classes for A level, and also don't forget to check out the other videos on my channel. Thank you and see you next time.